Hello, and welcome to this SRC Learning Essentials series video about Inter-AS Model B VPRN. If you are not familiar with the Service Routing Certification Program, you can learn more by visiting our website at www.networks.nokia.com/src. In this video, we will first discuss the need for Inter-AS VPRN and list each of the three models. We will then further explain the Inter-AS Model B VPRN control and data planes, followed by a lab session to configure and verify Inter-AS VPRN on the Nokia 7750SR. So, why use Inter-AS VPRN? Well, if two sites of a VPRN are connected to different autonomous systems, for example, because the sites are connected to different service providers, the PE routers attached to this VPRN will not be able to maintain IBGP connections with each other or with the common route reflector. Therefore, other options are required to distribute VPN IPv4 routes between the PEs, and these options are known as Inter-AS VPRN models. There are three models that can be used to interconnect a VPRN managed by different ASs: Model A, Model B, and Model C. Model A, which is also known as the VRF to VRF approach, is simple and easy to provision, but has limited scalability because it requires configuration per VPRN on the Autonomous System Border Router or ASBR. Model B improves the scalability of Inter-AS Model A by eliminating the need for per VPRN configuration on the ASBRs. It uses eBGP redistribution of labeled VPN IPv4 routes between ASs and therefore relies on a trusted agreement between the service providers to ensure end-to-end operation of the VPRN. Model C enhances the scalability of Inter-AS Model B because VPN IPv4 customer routes are neither maintained nor distributed by the ASBRs. Instead, multi-hop eBGP redistributes labeled VPN IPv4 routes between the source and destination PE with eBGP redistribution of IPv4 routes between the ASs. The remainder of this video will focus on Inter-AS Model B VPRN. In Inter-AS Model B VPRN, the ASBRs pair with each other using MP eBGP to transport VPN IPv4 routes between autonomous systems. This model is also referred to as MP eBGP for VPN IPv4 exchange. PE routers in an AS distribute labeled VPN IPv4 routes to their ASBR via MP IBGP sessions. The ASBR then redistributes the VPN IPv4 routes to its eBGP ASBR peers with a new service label. If there are multiple VPRNs with sites attached to different autonomous systems, it is not necessary to have a single ASBR in the AS hold the routes for all VPRNs. Multiple ASBRs may be used, with each holding only the routes for a particular subset of VPRNs. Note, there is a dependency between the route target values used in the two ASs. The route target exported by PE1 for a VPRN must be imported by PE2 for that VPRN and vice versa. As previously mentioned, the Model B approach accommodates the use of MP eBGP between ASBRs to transport VPN IPv4 prefixes. This is similar to the MP IBGP implementation used in traditional VPN networks within a single AS. The only difference is the way the next hop attribute is handled. Over an eBGP session, the ASBR sets itself as the next hop before advertising the route to its peer, and thus must also advertise a new label. In this example, CE1 propagates the IPv4 route 192.168.1.0/27 to CE2. First, CE1 sends the route 192.168.1.0/27 to PE1 as an IPv4 update. PE1 adds the route distinguisher and route target to the IPv4 route, allocates VPN label v1, and sends the VPN IPv4 route to ASBR1 via MP IBGP. ASBR1 accepts the VPN IPv4 route and sets itself as the next hop because it is propagating the route outside its own AS. ASBR1 also assigns a new VPN label v2 and sends the VPN IPv4 route to ASBR2 via MP eBGP. Next, ASBR2 assigns a new VPN label v3 and propagates the route to PE2 using MP iBGP. And finally, PE2 accepts the VPN IPv4 route into the customer VRF and distributes the IPv4 route to CE2 via the configured PE to CE protocol. It is important to note that the route target never changes throughout the route propagation process. Let's now look at the data plane and how CE2 sends an IP packet destined to 192.168.1.1. First, CE2 forwards the data packet to PE2 via the VPRN interface. PE2 pushes two labels on the IP packet, the VPN label v3 and the transport label L2, and forwards the packet to ASBR2. ASBR2 pops the two labels, pushes VPN label v2, and forwards the data packet to ASBR1. ASBR1 pops the VPN label v2, pushes two labels, VPN label v1 and transport label L1, and forwards the packet to PE1. Finally, PE1 sees that VPN label v1 corresponds to VPN A, pops the two labels, and forwards the IP packet to CE1. Here, it is important to note that the directly connected interfaces between the ASBRs forward packets encapsulated with only a single label, that is, the service label. So, Inter-AS Model B characteristics can be summarized as follows. It relies on a trusted agreement between the service providers to ensure end-to-end operation of the VPRN. There must be coordination of the RTs used in the ASs, that is, the RT exported by one AS must be imported by the other AS. The ASBRs establish a single MP eBGP session. ASBRs process VPN routes but do not require the configuration of VPRN instances. This also improves the scalability of Inter-AS Model A. Routes are exchanged between the ASBRs as labeled VPN IPv4 routes, and finally, ASBRs maintain a mapping between receive labels and advertise labels. This mapping is used in the data plane to ensure the proper swapping of VPN labels as the data packet passes through the ASBR. Next, we will move to our lab environment and complete this case study. There, BGP sessions between the PEs and CEs are pre-configured. MP iBGP sessions between the PEs and ASBRs are also pre-configured. We will configure Inter-AS Model B VPRN for VPN A and verify its route propagation. Alright, let's first view the VPRN services on the PE routers to verify a key requirement where the route targets must be the same. So here on PE1, show service ID 100, which is the service ID of the VPRN service in our example. Base. And here we can see the route target is set to 64496:10. Over to PE2. And we can see that it is configured the same at 64496:10. Let's now complete the Inter-AS Model B configuration. We will need to enable Inter-AS VPRN and configure an MP eBGP session between the ASBRs. So starting with ASBR1, configure router BGP, enable Inter-AS VPN. This is the command that enables an ASBR to store received VPN IPv4 routes in its BGP table, even though it has no VRFs that import these routes. Now to configure the MP eBGP session to ASBR2. Group, and we'll call this ASBR, family VPN IPv4, Inter-AS, it's 64497, neighbor 10.1.2.2, and now over to ASBR2. Configure router BGP, enable Inter-AS VPN, and configure the MP eBGP session. Group ASBR, family VPN IPv4, Inter-AS, and it's going to be 64496. Neighbor 10.1.2.1. To verify the session, let's run show router BGP neighbor 10.1.2.1. And here we can see that the state is established. Now that the Inter-AS Model B VPRN configuration is complete, let's verify the routing table on CE2. So show router route table. And here we see that the remote customer prefix 192.168.1.0/27 was learned via the BGP protocol. Heading over to PE1, we can begin to look at how 192.168.1.0/27 is propagated through the network. Let's start by viewing VRF 100. Show router 100 route table. This output shows that the IPv4 route has a next hop of 10.5.9.9, which is the far end interface of CE1, and was learned via the BGP protocol. Next, let's view how PE1 advertises this route as a VPN IPv4 route to ASBR1. Show router BGP neighbor 10.10.10.1. Advertised routes VPN IPv4. Here we see PE1 sets itself as the next hop and then forwards the VPN IPv4 prefix to ASBR1 with a VPN label of 262.140. Now moving over to ASBR1 to verify that the prefix is advertised to ASBR2 as a VPN IPv4 route. Show router BGP neighbor, and this is an eBGP session, so we use the far end interface address of 10.1.2.2. Advertised routes VPN IPv4. And similar to PE1, ASBR1 first sets itself as the next hop. However, it advertises the route to ASBR2 using a new VPN label, 262.142. Over to ASBR2, where we will view the advertised routes one more time. Show router BGP neighbor 10.10.10.6, which is PE2. Advertised routes VPN IPv4. And here ASBR2 sets itself as the next hop, assigns a new VPN label 262.139, and advertises the route to PE2. Another useful command for viewing VPN labels within Inter-AS VPRN is show router BGP Inter-AS label. This command can only be performed on the ASBR and shows all received and advertised BGP Inter-AS labels for each next hop. From this output, we can quickly see that ASBR2 received the label 262142 from ASBR1 and then advertised the label 262139 onto PE2. Finally, let's view the received routes on PE2. Show router BGP neighbor 10.10.10.2 received routes VPN IPv4. And here, as expected, the customer prefix 192.168.1.0/27 is now flagged as used. And that does it for this video on Inter-AS Model B VPRN. Thanks for watching and see you next time. Content for this video was adapted from the Nokia SRC Virtual Private Routed Networks course. You can access the complete course via any of the 3 learning formats shown in this page, as well as get remote private access to a service router lab to complete the course lab exercises. If you are interested in obtaining an SRC certification, this table identifies the recommended courses and required exams for each of the 5 available certifications in the program.